Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain synthesis of carbon nanotubes. There are three methods are available for the synthesis of carbon nanotubes. They are carbon arc discharge method, laser ablation method, chemical vapor deposition method. This is also known as CVD method. Now coming to the first one, carbon arc discharge method. This is the diagrammatic representation of carbon arc discharge method. It is consists of pressure transmitter. This one control the pressure inside the chamber. And here, this is the electrode connections. One is connected to the anode and another one is connected to the cathode. And here, to avoid the chemical reactions during the process, we are passing the inert gas. This is the gas inlet and this is the gas outlet. And this is the total construction of the carbon arc discharge method. So in this, two graphite electrodes are placed in between the anode and cathode. That means a carbon electrode is connected to the anode and another one is connected to the cathode. By passing high voltage, that means a high intensity of electric current through the anode and cathode. Then the graphite electrode at anode get discharged. That means it will be vaporized and it will be deposited on the cathode surface, which is the black deposit is called the carbon nanotubes. So here due to the applying high voltage, the anodic graphite is discharged and it will deposit on the cathode surface. So this is the main mechanism involving the arc discharge method. So this is conducted in a closed chamber. It is a stainless steel cylinder which can withstand at high temperatures. Here we are maintaining up to 1200 degrees centigrade temperature. Due to that high temperatures and inert atmospheric condition. That means we are passing the inert gas like helium, neon, argon. So such kind of inert gas is passes through the chamber. This one is for the avoid of chemical reactions during the discharge of the anode. Now coming to the key points, this experiment was conducted by the Sumio Lisma in 1991. This technique is also used for the synthesis of fullerenes and carbon nanotubes. For the construction of fullerenes, we are also using same method. And next one, it consists of the reaction chamber containing two graphite electrodes are separated by the short distance of usually 1 to 4 millimeters. So this is very close to each other, the anode and cathode. And this chamber is filled with the inert gases such as helium, argon, nitrogen. So they are the inert gases. We are passing the inert gas. Here this is the gas inlet and gas outlet. The next one, a current of around 18 volts is applied across the electrodes. So high intensity of electric current is passes through the anode and cathode. Then the carbon atoms are ejected from the anode and deposited on the cathode surface. So by applying the high voltage, the particles from the anode, that means the carbon particles are ejected from the anode and they will deposit on the cathode surface. And the black carbonous deposit contains the carbon nanotubes. Here the deposited carbonous black containing the carbon nanotubes. And the produced carbon nanotubes will have less structural defects and better properties. So in this type of formed carbon nanotubes are having the high strength and stability. And by using this method, we can fabricate it up to 60% yield of carbon nanotubes. This is the carbon arc discharge method. So this is the theoretical explanation about the carbon arc discharge method. So I want to show some video which is related to the arc discharge method used in industries. This is the original representation of the carbon arc discharge method instrument. This one is completely stainless steel container. I'm showing the video. This is the gas pipe which is used for passage of the inert gas, and this is the anode. This anode having the carbon electrode, and this is the cathode. This cathode drum having the deposit carbon black deposition. This one is the carbon nanotubes. So after discharge, the carbons are deposited on the cathode surface. This is the some images of the carbon nanotubes. After discharge, we will check the carbon black in some analysis, which will confirm the formation of nanotubes. So these are the other form of the carbon allotropes. So this is the experimental video. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.